All right, section 6.3 on part 2, the only thing we didn't get to was graphing logarithmic functions. Since we're not able to just put any log in our calculator, again, our calculator can only handle base 10 or base E. To graph these, we're going to have to look at their inverse, okay? And so from the previous section, we know here, if this is my function, f of x, so this is my original function, and let's say, let's do this in two different cases. Let's do my base is greater than 1. So I have a base greater than 1, okay? Its inverse, the inverse of this function, I'm going to grab a different color, the inverse, we'll go pink, of this function, f inverse of x, would be this base b, to the x power, because we know logs and exponents are inverses of each other. Okay, and so from the previous section, we know here, if this is base b, and if my base is greater than 1, this is going to be a growth problem. So this will be an exponential growth problem. Okay, and it's going to pass the y-axis here at the point 0, 1. Okay, and it's going to have this nice bit of a growth, yeah, let's get that in there, growth curve like that. So this is the inverse function. Okay, f inverse of x, okay? But we know from the previous, I don't know, a while ago, that inverses actually have some symmetry. So if I actually graph the line y equals x, so there's the line y equals x. If I graph that line y equals x, this function is going to actually be reflected. This orange function here, my original function, is going to be a reflection over that axis. So instead of going through the point 0b, this is the point 0b, b is your base. So you put a 0 into this, b to the 0 is just b. It's going to actually go through the point b0. So it's going to go over here through the point b0. Okay, and it's basically going to be this reflection, so it's going to look like that if we reflect it over. So this is my f of x. Okay, so it's going to look a bit like this. Hey, one thing is this function is never ever actually going to cross this x-axis. Sorry, that y-axis is straight up and down, and we actually refer to this line here that it never crosses. It's never going to cross this line here. It's always going to be to the right of that green line. We call that a vertical asymptote because it goes straight up and down. It's a vertical, and here's how it's spelled, asymptote. It's a vertical asymptote. It's a line that this function gets really, really, really close to but never crosses. Okay. And then what we can see then here is we can't actually put, for my domain and range of this orange function, for my domain and range, we can't ever put a negative into this. So for my log function here, my domain is only positive numbers. X has to be greater than 0. And I can't actually even put a 0 into this function. Okay? And if we look at, let's go just log base 10 in our calculator, the log of 0, it says domain quit. It's an error in the domain. Okay, because you can't actually put a 0 into this because there's no way I can take a number to a power and get out a 0. There's also no way I can take a number to a power and get out a negative. Okay, because if we look at this pink one and how inverses work, for this pink one, the domain is all real numbers. I can put any negative, any positive in there. The range on this one is going to be only positive. Y has to be greater than 0. So the only thing I'll get out here is greater than 0. Okay. So since inverses, again, remember inverses, a function and its inverse, the domain and range flip-flop. So here, since the range of my exponential function is y is greater than 0, then that means that's